When I'm older, I've always wanted to be a chemical salesman, so I'm going to try to follow in my dad's footsteps.
We see children who are more interested in science now than we ever have.
I love science because it's just interesting to find out different things about what's going on.
Science is so exciting, it's so relevant, and it's always changing. There's always new and cool things that you can learn about.
When I get older, I want to study meteorology because I like the weather and I like predicting the weather.
Science is important because it helps develop critical thinking skills that everyone will be able to use later on in life.
Science education for us should be at the top of our priority list.
Science is important in life because it gives students and everyone else the skills that they need to be able to figure things out on their own.
Science is important for everyone to learn because it applies to everything that we do. So math is not isolated. Economics issues are not isolated. And music issue, things in music are not isolated. Inquiry, discovery, experimentation, but then beyond that, the actual way that things work. How do things work? It's science.
I like science because you get to see the world differently and think about things like just walking in the hallway. You get to think about the way the lights move.
I want you to show me the flow of electricity.
If we can start with students coming to grip with everything that you want to know, every problem that you want to try to address in your life, might start with figuring out the science that's associated with it. So our hook for a lot of people who are thinking about pursuing science could be that science is everywhere.
Kids are naturally curious, and that's what science is. It's being curious and following up your curiosity with questions and experiments. When people tell me they don't like science, I can't understand it. Science is so exciting and fun. Figuring out how the world works is science.
Science is perfect.
The way that science has changed since I started teaching 11 years ago was whenever I first came into the classroom, we basically had a textbook. We didn't have a lot of materials to use with the students.
We tried to do labs as much as we could, but even the labs were more teacher-centered. There was more recipe-type science where I would give them a lab and kind of tell them what they were supposed to do, and they did it, and they enjoyed that. But they would work through the recipe and come to a specific ending.
Now it's very much more based on application of concepts and mastery of concepts learned. Standards are presented. Teachers find experimental ways, through using labs for students to actually learn the material so that they can apply it to the real world.
Now we do the lab first, and we have the kids figure out the knowledge from the labs.
Okay.
It's a lot more fun, and it's a lot more exciting, and it builds a much broader and deeper skill set. So instead of being good at kind of taking notes and regurgitating, you have to be good at working in teams, you have to be good at critical thinking, you have to be good at problem solving, you have to be good at putting a bunch of pieces of data together and figuring out the whole from that. Okay, that looks cool. So what color are these?
And now, they come into my room or they come into the teacher's room and things are set up and they look and they go, what is that? And what are we going to do today?
Mostly lit up the light bulb using wires and some batteries.
It's a lot more me giving them something and they kind of work through it on their own. They have to decide what the ending's going to be. But what I want you to be thinking about is where's the electricity flowing through the circuit? They might know the topic that we've been working on. They may know what the overlying concept is, but they have to come up with a way that it all ties together.
The very first time they came in here to do the light bulb, all I gave them was a D-cell battery, a wire, and a bulb from a flashlight. I want to see if you can light this light bulb. Do it. And they tried, and they tried, and they giggled, and they laughed, and they looked to see what somebody else was doing, and then finally one group, one pair of partners, lit the light bulb.
Oh, we got ours lit.
All right. Well, they all jumped up to go run and see how they did it. And oh, I get it now, I get it now. So it's those moments that make it worthwhile, when they finally figure something out on their own.
Today we used some new clips for the batteries and clips for the light bulb to use, and it helped us hold the wires in place better and light up the light bulb.
The kids are taking to science by getting extremely interested in the hands-on parts. They like to figure things out for themselves. They don't feel like it's as much of a traditional classroom.
It's just exciting to watch everything react and how everything works.
It's exciting for me to say, to keep pulling and trying to get them to just keep asking questions and questions, and I'd never give them the answer on just why, how, why, and they're used to it by now, but at the beginning of the semester it kind of freaks students out, that they're used to teachers just kind of giving them the answers, and that doesn't happen. They really have to work to get the answers.
She doesn't tell us the answers, she tells us how to do it, but we have to get the solution, figure out how to do it, and what's the outcome of it on ourselves.
They see the immediate effect of what happens when we're using the science in our labs and in our hands-on experiments. That gets their mind moving. That gets them thinking. They are able to problem solve a whole lot better with that than they are with anything you put on a page and ask them to read and develop an answer to.
They come in excited and ask, what are we doing now? What's the next thing we're doing?
Science is awesome. It's amazing.
So this State Museum of Natural Sciences is a remarkable resource. It stands as one of the most innovative museums of its kind in the country. This is a huge resource that provides learning opportunities, learning and teaching professional development opportunities, unlike anything in the classroom. So classes can come here and book deep time to get into science in one of our Investigate labs, or they can, for younger groups, they can be scheduled into our Windows on the World experience with live animals and about the workings of nature and natural processes. So when the museum thinks about its target audiences, teachers of science at any grade, from pre-K to high school and into university are a particular target of interest. We need to, and we can, assist teachers to be more confident and able to teach science. We take teachers on field trips to Belize to look at the onshore and offshore ecosystems. We take them to Yellowstone. This enlivens their interest about the resources which they can then use on their own out of the classroom, but we're integral to that educational system by being an informal resource with which I think teachers need to see our value more and more, that we can do things and engender interests in ways that are not possible in the classroom. So as we say in the museum business, we're living in a glocal age, the integration of local and global, and we have to live that reality because that's the world that students are growing up into. As a luminary in our field said recently, research not communicated is research not completed. And museums have to occupy that space of building a bridge between the frontiers of research and what the public knows. And that traditionally has been a very wide boundary in which where it would be unusual for a school student or a parent, somebody of any age or stage of learning, to be able to actually meet and converse with a scientist. We break down those boundaries here.
Looking across the K-12 continuum in education and tracking who's in a science class, whether it's boys, girls, minorities, or non-minorities, looking across K-8, the scene looks fairly balanced. You don't see much disparity. But once you move into the higher levels, at high school, where there comes that selection of which courses a student will take, that's where you start to see students starting to group themselves a little bit differently. The reasons behind that vary from students not receiving the prompting from either their classroom teachers, their peers, parents at home, or even the selection system within the school itself. What we're most interested in, not so much as what the reason is how can we encourage these students to go into the science classes once we identify that there's a problem? Because the problem doesn't exist in every school, but it's up to every school to look at their science classes, the upper level science classes, and say, well, who's taking our classes? What can we do to encourage girls to get into this class? What can we do to encourage minorities to get into that class? And sometimes it's just as simple as pulling them in and say, why didn't you take this class when you could have taken this class? And sometimes you have to say, as I've said to students, oh, you will be taking this chemistry class next year. Thank you, have a nice day. So the reason isn't always as important as to why it exists as to, but what are we going to do about it now that we know it's here?
One of the focal points of our interest is the diversification of the audience. Just because the museum is free does not mean that our visitation naturally mirrors society at large. We are reaching into the 80 or so counties which are characterized by so-called underserved populations. And I think we're particularly successful because of the nature of the learning environments here, both for teachers and for students, at making this a very gender-balanced opportunity. The majority of the staff of the museum are women, and most of our scientists are women. We are conscious of employing role models in our labs which are visible to the public by traditionally what has been an underrepresented gender in science.
Science can be seen in everything, and we can use that to get more minorities and more women involved in it. A lot of times they just don't see the need or see the joy that's associated with it. The answers vary as to why the problem still exists. The solution is still the same. You have to be persistent in discovering an answer for it and say failure is not an option. We cannot allow this to continue. Find the problem. Find a solution.
For me, science education in high school is our opportunity to show students the world beyond high school. And I see us as being that stepping off place to career and college readiness in science.
We have a tremendous opportunity to supply all of the businesses with children that could go ahead and become productive citizens in the science industry, and it should be a top priority for us.
We need all the scientists and inventors that we can have from these children that are coming up, because they're the ones that are going to be the next leaders, and they need to be able to problem solve. Reading, writing, math, and science intertwined together, and they need to be well-rounded, and they need to know how to think. And with science and inquiry, they can figure out things.
So the value of a place like this, the Museum of Natural Sciences, goes way beyond our role to assist education and assist lifelong learning. With the research triangle here, which was nourished by science and technology-driven industry, obviously we're part of a workforce development pipeline that to engender interest here in the museum of students is to inform them about career choices and career opportunities.
Science is vital to our economy. Science is developing all the new technology that we are using. Science is solving a lot of problems that we are facing and potentially having in the future if we don't solve them. Building and developing and solving problems are huge parts of the economy, and all of those things happen because of science.
Science is cool, fun, and awesome. Oh yeah.
Science is the best.
Science is liberating.
Science is fabulous.
Science is opportunity.
Science is cool.
Science is fun.
Science is hope.
Science is understanding.
Science is relevant.
Science is everywhere.